Okay. Am I audible over the web? Yeah. So what is the answer? What is the answer of it? Baba, instead of and you have to use or. No, sir. What is or? Execute that or this. No, definitely that is not the case. Yeah, Madhavi, you are right. Actually, there was no error. Actually, there was no error. Okay. Yes. Thank you. నేను చూపించిన దాంట్లో అసలు తప్పే జరగలేదు. I have just shown you the command, not the output. I have shown you the command, not the output. ఎప్పటికీ అర్థం అవ్వలేదా? అద్భుతంగా ఉన్నారు మీరు అందరూని. Okay. Let us quickly start with that. Okay. So make their test cd test vi docker file from openjdk :8. Okay, and then arc db ip equals to 0.0.0.0. Okay, run echo $db ip. Okay, I might have taken an Alpine image if I'm not wrong. Okay, fine, whatever it is. Right. Okay. And then cmd. First, let me speak about the first problem, and then I'll come back to the second one. Okay. First one. Docker image build -t test :0.1 and my current file is not. Okay. So over here are you saying echo dbap? For every command it will show what was the command and what is the output. Okay. In the last class, I was just trying to tell, okay, why you are using $dbap? No one had answered me saying that there is 0.0.0.0 in the bottom. Okay. So, మీరు కనపడుతుందాన్ని చెప్పలేకపోతే రేపు పొద్దున ఇంటర్వ్యూలో నిజం చెప్పినా ఆర్ యూ షూర్ అంటాడు. నో ఐఎమ్ నాట్ షూర్, వాట్ ఎవర్ యూ ఆర్ టెల్లింగ్ ఈజ్ రైట్ అన్నాడు. Okay, there was nothing wrong in this, first of all. Okay, everything was working. Okay, you have looked at the command, not at the output. అర్థమైందా? దీన్ని ఫైండ్ అవుట్ చేసుకోవడానికి 2 రోజులు 200 మంది ఓకే తీవ్రమైన మేధస్సును అప్లై చేసి కూడా తెలియచుకోలేకపోయారు. నేను అన్నాను కదా, ద మోమెంట్ ఐ టెల్ ద ఆన్సర్, ఓకే, విల్ బి లాఫింగ్ ఆన్ అవర్ సెల్స్. వాట్ వాజ్ ద ఫస్ట్ ప్రాబ్లం? దెర్ వాజ్ నో ప్రాబ్లం అట్ ఆల్. Okay, you are looking at the wrong place. Whenever you write, it will first try to tell what is your command, and then it will execute the command, it will write the output. Did we got 0.0.0.0 over here? Okay, ఇక్కడ అక్కడికి అర్థమవుద్దేమో అని ఇంకో ఎగ్జాంపుల్ తీసుకుని దాంట్లో ఆర్గ్యుమెంట్ వాల్యూ ప్రింట్ చేశాను. Yes or no? In the other example, I have taken one argument and I was able to use that. Okay, even then no one got doubt. So first time it was not working, second time it was working. I said, man, wonderful. Clear? Okay, so this will work. And what is the other thing which I have done? Okay, now let me try to write a Docker file. I have said that in echo over here, I was trying to write something called as db ip. Okay, someone was trying to tell that, okay, put that in quotes, okay, put percentage symbols. Okay, I got all the answers. Okay, apart from doing black magic, I was being asked to do everything. Okay, let us see what happens now. So I'll put it as 0.2. Now I'll try to run this docker container run. Okay, what was it? Test colon 0.2. Whatever I have written, I got it. Okay, now if you find out why it is happening, if you remember me speaking about docker file, I said that while you are writing docker file, you have two ways of doing the thing. One is you can write in this format. The other one is you can directly write the commands how you write in a Linux file. Okay, so if you have any variables, never ever use this format. Use a Linux kind of a format, because Linux format is called as shell form. Okay, it is your shell which understands to expand variables, not exec format. Let me try to do this now. $dbip. Let me build the image. Let me call it as 0.3. Okay, and docker container run 0.3. Okay, what has missed this? ఇది మిస్ చేశాను ఇక్కడ. You don't require quotes. Four kada? Yeah. Oh, first you have to build the image, right? 0.4, and then okay. So over here I got the value. Why did I got the empty value? What is that I was using there? Argument or environmental variable? What is the lifetime of argument variable? Building the image. Will it have any value while you are running the container? No. Okay, so the basic stuff is now there is no environmental variable called as, because this is argument. Now if I change this to env, let us see if this will have any impact. Okay, is it working? So that's it. Is this not all the three concepts which I have spoken about? Argument will have a lifetime only while you are building the image, whereas environmental value will have a value while you are building the image as well as when your container is running. Okay, while you are running in your container, you can change the value of environmental variable. While you are building your image, you can change the value of argument. Okay, adi idi find out cheyalepoyamma. It has hardly taken 5 minutes, right? Okay, so if you get confused to the questions like this in the interview, even though your answer is right, people will try to tell you that, okay, are you sure, ఇలాంటి మాటలు వస్తాయి. Then you say, no, I am not sure. Okay, so I forgot, I have a problem with my memory. You have to speak about all of this now. Okay, now am I getting 1.0.0.0? Because this is an environmental variable and I can set the environmental variable value while I am running my container. Default value was 0.0.0.0 and now I have changed it to 1.0.0.0. Yes or no? Yeah, two problems. First problem, no problem at all. You are looking at a wrong place. Second problem, you are trying to use a expression where you are not supposed to. దానికి నాకు రకరకాల ఆన్సర్లు వచ్చినాయి, ఎక్కువ వాడండి. Okay, right? No, if you have read through the docker, remember I have said to read the docker file instruction for everything. If you would have read the docker file instruction, there it is clearly written that whenever you are using the square bracket, that is exec form, it cannot expand variables. Expand variables means it cannot substitute the values with your variables. If you have to use any dynamic behavior, if you want to use arguments or environments over there, right? Or any environmental variables over there. Don't use exec format, use a command format. That means write that in the format of Linux script. ఇది ఫైండ్ అవుట్ చేయలేకపోయాం. అది నిన్న నేను అంత మిమ్మల్ని అంటానికి కారణం ఏంటో అర్థమైందా ఇప్పుడు? 3 basic problems. Okay, so which draws me to a conclusion saying that 80% of this classroom is not practicing. 20% of the people, I am not worried whether they have given right or wrong, they have tried something. Okay, rest of the 80% not worried. Okay, కోర్స్ అయ్యాక ఉద్యోగం వస్తుంది, నాకు జ్యోతిషుడు చెప్పాడు, ఉగాది తర్వాత ఇంకంతా శుక్రమహారదశ నాకు, రైట్? ఇలా ఎవరన్నా ఇంకా నమ్ముతా ఉంటే అవి ఏం పని చేయవు. ఓకే, మీరు శుక్రమహారదశ అని ఎలాగైతే సినిమా డైలాగ్ చెప్పారో నేను అలాగే ఇంకో సినిమా డైలాగ్ చెప్తాను, రైట్? గుండ్రంగా తిరిగే భూమికి వాస్తు ఏంటి, రైట్? ద హోల్ వాస్తు డజంట్ హ్యావ్ ఎనీ మీనింగ్. ఓకే, it will have a meaning if your earth is in the format of table, but is our earth in the format of a table? మనం మాట్లాడే ఈశాన్యం నైరుతికి ఇట్లకి అర్థం లేదు. ఓకే, ఇన్ని మాట్లాడి నేను వాస్తు ఉన్న ఇల్లే కొన్నాను, ఎందుకంటే తర్వాత అమ్మటం ఈజీ అని, అంతే, అంతకు మించి వేరే రీజన్ ఏమి. ఓకే, దట్స్ అ హోల్ పాయింట్. ఓకే, సో జాతకాలు జ్యోతిష్యాలు అవి, మరి మీరు 3 ఉంగరాలు పెట్టుకున్నారు కదా, రైట్? దీస్ 3 were given to me by my relatives. ఇందులో ఒకటి తీసేసాం అనుకోండి, మా అమ్మకు కోపం వస్తుంది, నీకు అంతా మీ నాన్నోళ్ళ వైపే ఇష్టం. ఒకటి నాన్నోళ్ళ వైపు నుండి వచ్చింది, ఒకటి అమ్మోళ్ళ వైపు నుంచి వచ్చింది, ఇంకోటి మావిడోళ్ళ వైపు నుండి వచ్చింది. సో నమ్మినా నమ్మకపోయినా తప్పకుండా వేసుకోవాలి. దట్స్ అ హోల్ ప్రాబ్లం. దట్ డజంట్ మీన్ దట్ ఐఎమ్ స్ట్రాంగ్ బిలీవర్ ఇన్ ఆల్ ఆఫ్ దిస్. అర్థమైందా? రైట్? సో నేను చేసే మీకు చెప్తాను, నేను చేయకపోతే మీకు చెప్పను, నాదే తప్పని చెప్తాను. రైట్? Okay, right. So did you got to understand the problem? So what is the first thing? In argument we didn't have problem at all, and when I was trying to use that java -jar, I am not supposed to write java -jar. Okay, if I want to have anything dynamic, I cannot write this java -jar and then $location or something like that. I'm quite sure that I've written something like this. Yeah, so I'm not supposed to use this because this will never work. Okay, if you want to use any dynamic behavior over here, just write java -jar and give a variable over here. This will work. Yeah, okay. And then whenever you're defining your environmental variables or arguments, let us assume that I have env dollar or env location, and I've given the value as something. Okay, location annam kabatti let me call it as spring -pet clinic dot jar. Okay, right? So and then I have written something called as arg test 1.0. Okay, so the value of argument is what? 1.0, and I cannot use test over here because the problem is arguments value will be alive only as long as you are building the image. But if you understand, cmd and entry point are the commands that get executed while you are starting your container. By the time you start your container, argument is dead. The only thing that is ever alive is environment. Am I clear on this now? So do we understand our mistakes? Okay, good. Right then. Okay, there is no need to do into all of that. So nenu export lu linux lu antemo cheppala. I have asked a very basic thing. I said yesterday I have given a clue also. Okay, just execute it, watch the output, you will come to know what is your mistake. Okay, yes or no? I have been telling this. Yeah, okay, right. You are unable to hear my voice. That is the right time which you are unable to hear my voice. Okay, fine then. So let us get back to our problem statements at this moment. Okay, so which brings us to Kubernetes. Okay, so fine, right? So yesterday I think we have basically we were attempting to write a YAML by looking at a API reference. Today what we will try to do is we will try to understand the whole conceptual overview of Kubernetes. Okay, at a decent level, and then we will start applying all of this while writing specifications. So for the people who have not tried writing a specification, you have time today also. go to the API reference. Remember yesterday what I've done? I want to go to the pod. I've clicked on API reference. There was a document that has opened over there. I started writing a YAML file, okay, with something called as API version, and then there was something called as kind, and then there was something called as spec. There was something called as metadata. These were the 4 fields which I've basically written. Okay, right. So today let us try to get into some terms of Kubernetes. Some terms of Kubernetes. So important concepts of Kubernetes. The first concept is namespace. So what was an object? Object was a record of intent. Okay, so whenever you can save anything in Kubernetes, okay, that is something which we call as object. So for example, pod is an object, okay, volume is an object. So anything which you can store in Kubernetes or save in Kubernetes, to be very specific, which you can store in etcd, that becomes object. And now what is a namespace? Okay, now think of in this way. etcd tries to store your objects in some folder. etcd tries to store your objects in folder. It is not folder, I'm just giving you that perspective. Okay, object is storing something. Now that storing happens in some folder. So let us assume I have a folder called as X. Whatever objects I'm storing, I can store it in a folder called as X, or a folder called as Y, or a folder called as Z, whatever it is. So I can go on and on. Okay, so if you think in that way, that folder is something which I can call as a namespace. Okay, so why do I need to have a folder? Let us assume that I have one Kubernetes installation. Okay, I have kubeadmin running with 10 servers. In the 10, I want to run dev environment, I want to run test environment, and I want to run UAT environment. Ideally, what should you do? Kubernetes is one cluster. So you have to create 3 deployments or 3 installations. What Kubernetes says is, I can give you a logical cluster also. Physical cluster is where you have installed kubeadmin. Logical cluster is where you can create something called as a namespace. Okay, so what is a namespace now? Namespace is nothing but a logical cluster. Namespace is nothing but a logical cluster. Okay, there are some objects which do not fit in namespace. That's okay, we'll worry about that later. Okay, so for example, in one Kubernetes, if you want to maintain various different environments like dev, test, QA, all in one Kubernetes cluster, right? Then it will be very difficult, because you will be having dev clusters pod also with the same name, test clusters pod also with the same name. Okay, you will have name conflicts. So for example, our application is Swiggy. In dev also we'll be calling it as Swiggy itself, right? Yeah, so unnecessarily you have to go and change your specifications, your pod.yaml files, by saying that since it is a dev environment, I'll be adding dev slash. Okay, so if that is the case, you have to write a YAML for every environment, which is not a good idea. So what Kubernetes tries to tell you is, you can create something called as a namespace. Namespace is all about, okay, to create virtual environments. For example, in this what happens is, your pod names are identified by a namespace slash name. So for example, there is no need for you to call your pod as dev Swiggy. You can just call your pod as Swiggy in all the environments. But when Kubernetes looks at it, okay, your Swiggy pod, which is in dev namespace, is doing one kind of an activity. Your Swiggy pod, which is in QA namespace, is basically belonging to that. So it is a way of creating virtual clusters. So let us get started. I'll give you some links. Please, see, giving me giving the links is happening every day, but I'm not sure whether you are reading that enough or not. Okay, so whatever I'm going to speak in Kubernetes is already present over here. Okay, right? Even the whole application journey I've written it over here. Whether you read it or whether you don't read it, it is your choice. Okay, every day I am giving the links. Okay, fine. Now let us get into it. Kubernetes namespace. Okay, so Kubernetes supports what? Virtual clusters. Remember, when we have gone into this AWS, we have created 2 servers. In that 2 servers, we have said that, okay, I have 2 servers. One will be a master, the other one will be a node. That was a physical cluster. You have taken machines and you have literally installed a cluster, right? So, but namespace is a virtual cluster. And Kubernetes already will have some namespaces. Okay. So let me get into it and let me start my cluster. Okay. So once we understand these concepts, then we'll be increasing this cluster, and then we'll be making the deployments. All right. Fine. I want the master node to be up. Okay. Good. So okay. So first cube ctl get. So are you seeing there are some namespaces already over here? Okay. In Kubernetes, when yesterday I tried to create one pod or two pods, whatever it is, right? So if you don't specify any namespace, they will end up in default. They will end up in default. And then are you seeing some other namespaces over here? Kube system, kube public, kube node lease, and all that stuff. Those are system namespaces. That is something which is used by Kubernetes to maintain its cluster. అది Kubernetes వాడుకునే namespaces. You cannot mess up with that. Okay. Those are required for the Kubernetes to basically maintain that stuff, right? So now if you basically go over here, okay. So Kubernetes, you can get the namespaces over here. Okay. Let me basically. What is the namespace? In Kubernetes, we can create virtual clusters. We understand the term virtual cluster, right? In one Kubernetes, you can have dev environment, which is running the similar pods, test environment, which is running the similar pods. For dev, we have separate users. For test, we have separate users, because on every Kubernetes namespace, I can give a different users, right? Or different role-based access control. So every virtual cluster will have different set of users. So in QA machine, your testers might have admin permissions in QA namespace. But when it comes to the dev environment, they might not have even access to it. So if you want to manage that kind of a functionality, you can do that using namespaces. Okay. Is namespaces required for the Kubernetes to work? No. If your company says that in this I am running only production and it has to run only on production, then you don't need a namespace at all. Run it on default. Run it on default. All right. Okay. So using namespaces. But if you want to understand namespace, just think of this. Okay. Think of your object as a file, and think of your namespace as a folder, right? So for the two folders can have two files with the same name, yes or no? But one folder cannot have two files with the same name, yes or no? So can you create a folder called as test, and in that can you create two files called as 1.txt and 1.txt? Is it possible? No, right? So to avoid this namespace naming conflicts, also we will be basically creating namespaces. Clear on this? Okay. So this will basically get the namespaces. Okay. And now if you want to create the namespace, okay, so or basically he's trying to tell you the declarative way of how do I insert the namespace. Okay. So for example, he's running a pod. He's running an pod in which Nginx is available, but he's trying to tell what is the namespace of it. So while running my pods or while running my workloads, I can specify which namespace they belong to. Okay. This namespace will have implications on your DNS name also. Tomorrow, whenever you want to resolve the DNS name, what is the DNS name? It is like a host name. So for the host name of whatever you are going to do, your namespace will have some kind of implications. Okay, so what is namespace all about? We'll do these examples, but what is namespace all about? To create virtual separation between something that is running in your Kubernetes, we'll basically go with namespaces. Clear on that? Okay, so over here, okay, Kubernetes has given decent documentation on this, but we'll be doing this not today. Today, let us try to understand what are the different things that are available in Kubernetes, right? So how to get the namespaces, how to describe them, and all of that stuff. Okay, right. So one more command which I want you to basically understand is there is one interesting command in Kubernetes which is called as kubectl get or API hyphen resources. Are you seeing this? Kubectl API hyphen resources. Very, very important command. Okay, so the next one is API hyphen resources. Okay, all the different resources available in Kubernetes. So for this kubectl API resource, and over here are you seeing namespace is true and namespace is false and all of that stuff? Okay, so wherever you are seeing that namespace equal to true, that means that whenever you create a namespace, you can have two different things. So for example, are you saying nodes? Just because I have created a namespace, you will not have different nodes for that. But just because I have created a namespace, I can have my pods in one namespace, which basically cater. So for example, okay, now what is the namespace? Namespace looks like a, okay. So in Kubernetes, basically what is happening, we have a huge cluster. In this cluster, you can create whatever you want. Okay, but there are some resources of Kubernetes which can be separated by namespace, and there are some resources in Kubernetes which cannot be separated by namespace. So to create this cluster, what is that we'll be doing? Okay, let me take some images. Server icon. Okay, this is looking good. Okay, so for example, to create these clusters, we will take some servers. Yes or no? Yeah. Let us assume I have 4 servers. And what are these servers generally called as? So these are nodes. Okay. So on the nodes, basically what I'll do is I'll create. Let me call this as pod. Okay. Today let us restrict ourselves to only node and pod because these are the only two things which we know. Okay. So let us assume that I have one pod which is running on each machine. Okay. Now I want to create a namespace. Let us assume that if I create a namespace, what will be part of namespace and what will not be part of namespace. Let us assume that we have created a namespace called as my namespace or dev namespace. Okay. So in dev namespace, just because I have created a dev namespace, will I have 2 nodes who belong to dev namespace and 2 nodes which belong to the test namespace? The answer of that can be known. Are you saying kubectl API resources? Nodes. What is the value of namespace for this? False. Just because you have created namespace, you cannot tell that, okay, in namespace A, I'll have this node. In namespace B, I'll have this node. No, that is not possible. Okay. But what is the next thing? Pod. Let me go to the pod. Okay. So for pod, what is the namespace value? True. That means that, okay, let us assume the square bracket is a namespace. I can say that these two belong to the dev environment and these two belong to the test. Okay. So in this, what is happening? I am able to create a separation for pods, but I am not able to create a separation for nodes using namespace. So in Kubernetes, there are many resources, and for every resource, you will get this value. Okay. So for example, let me show you something interesting over here. Okay. So very soon we will be learning something called as storage classes. Okay. And your storage classes cannot be impacted with namespace. What is a storage class? Remember volumes. mounting volumes and all that stuff, right? So for understanding or for doing that better in Kubernetes, we'll be learning something called as storage classes, persistent volume claims, and all of that stuff. So when you basically create that, he's trying to tell that your storage class will not be part of a namespace. It can be used across namespaces. So for example, if you see node, my nodes are working for dev namespace and then test namespace. So if you see, my node is shared across namespaces, yes or no? Okay. In the same way, my storage also can be shared across namespaces. But if I am creating pods, my pod cannot be shared across namespaces. Pod belongs to a namespace. Am I clear on this? So namespace is a virtual cluster. So what will be part of that virtualization is what you are seeing over namespace. So in Kubernetes, what can be possibly present? That is all kubectl API resources. Am I clear on this? Yes. Whole of namespace. మీకు ఎక్కడ కన్ఫ్యూజన్ ఉందో అది చెప్పండి. Have you attended yesterday's class? Sorry, I am not repeating. Do that first. See, these are like serials. ఓకే, నిన్న అనితకి ఏమైంది, ఇవాళ అనిత ఎందుకు ఏడుతుందంటే నిన్న సీరియల్లో ఏమైందో తెలియాలి. నిన్న రాకుండా అనిత ఎందుకు ఏడుతుంది మళ్ళీ చెప్పనండి, నిన్నటి ఎపిసోడ్ మొత్తం వేయాలి. ప్లీజ్ గో త్రూ ద yesterday's class, right? So even though it sounds harsh, understand one thing, for the people who come regularly, I can speak about, because we have some relation with whatever we are speaking today with what has happened yesterday, right? Yeah, okay. మీరు నిన్నటి క్లాస్ విన్న తర్వాత మళ్ళీ రండి, కావాలంటే మొత్తం చెప్తాను. ఓ రోజు ఇద్దరం కలిసి భోజనం చేద్దాం అవసరం ఉంది, బట్ నాట్ with skipping the classes, no. Okay, we had lot of things happened over the weekend, okay, from that day, right? Okay, so are we clear on this? In one Kubernetes cluster, I can create multiple different virtual cluster. Some objects belong to the cluster and some objects don't belong to the cluster, right? So, and in Kubernetes, what is possible is defined by something called as API resources. We have seen an example saying that nodes do not belong to the cluster, whereas pods belong to the cluster, right? So I can avoid pod conflicts with clusters. So I can have two pods with the same name running in Kubernetes, but they are belonging to the two different clusters. That's the whole idea. Okay, right? Okay, then it is API resources, not policy sheet to be very specific. API resources, all the APIs that are supported by Kubernetes in your cluster at this moment. No, no, that is a supported list. That is read-only list to be very specific, right? Yeah. Okay, right. So fine. And the next thing, let us get into our workloads. I am quite sure yesterday we have spoken about pod, okay, and today we are going to extend that discussion of pod. Okay, so right. So let me try to find some images for pods. Kubernetes pod icon. Ida? Okay, fine. So we'll have a better than we lay there. This is looking good, but yeah, this one is better. Okay, so this is a Kubernetes, same thing. Okay, it's okay. Resize. Okay, so this is Kubernetes pod. Okay, so inside the pod, what is that we'll have? We have said that there will be some stacks. Okay, and then there can be running containers in this. Okay, so I'm not saying container, I am saying containers. Yes, so in one Kubernetes pod, how many containers can I have? Okay, how many containers can I have? There is no limit to it actually. Okay, it is your choice. You can have as many as you want. So let us try to put it in this way. So I have one or more. Is this okay to have 3 containers in a pod? Yes. Okay, so right, so but in this, one will be a sidecar container, the other one will be a main car container. One will be a main car, the others will be a sidecar container, right? So am I clear on this? So a Kubernetes pod can have more than one containers, right? Now, till when this pod will be running? Till when pod will be running? So for that, what pod has something called as restart policy. Today I'm not writing notes, you have to read the documentation. Today's intention is that. Okay, pod has something called as restart policy. If the restart policy is set to always, if the restart policy is set to always, and if you have only one container, okay, and if your container is deleted, okay, but your pod is not, container is stopped, that means the pod is not deleted, pod will be trying to run it itself. A pod can be deleted only when you do kubectl delete -f and then you try to delete your pod. Okay, so pod has a life cycle. Pod has a life cycle. So let us look at the pod's life cycle. Okay, so Kubernetes pod life cycle. Okay, I will be giving links to this documentation today. No classroom notes. Refer them. Okay, refer here, because I'll try to make it simple for you. Go through the whole documentation, you'll be learning a lot. Okay, you can attempt that certified Kubernetes certifications also if you are good at reading this. Okay, లేదు అనుకుంటే పరీక్షకి 30,000 రాసినోడికి 20,000. రైట్, ఓకే, ఎందుకంటే చాలా మందికి రాదు కాబట్టి ఎక్కువ తీసుకుంటున్నారంట దాన్ని, నాకు తెలియదు. Okay, so if you look at it, your pod can be in the following states. It can be in the pending state, it can be in the running state, it can be in the succeeded state, it can be in the failed state, and in the worst case, right, if the status of the pod cannot be known to the Kubernetes due to various reasons, right, so then you will get a unknown state. So pending state, so Kubernetes has accepted to create a pod, okay, but it has just done. So yesterday I think whenever we said kubectl apply and then we have said kubectl get pods and -w, the first state was pending and then it was basically converted into running. So running means the pod is basically connected to the node and it is basically still running. And succeeded, okay, succeeded means all of your pods have been, all of your containers in the pods have been stopped, they are not running. Okay, they have been running, they are not terminated but they have stopped. Succeeded ante pod run avutunnattu kada, pod lo unna container alni aagipoyinattu. That's where I have to basically speak about this, right? Okay, and then failed. So terminated is, so generally what is terminated and what is succeeded? Whenever you run a Linux statement, Linux command, you will get a return code, you will get a return code. What is success for a Linux command? 0. What is failure? Anything other than 0. So in your CMD or entry point you write some Linux command, right? Okay, so if that command has returned by giving 0, then for Kubernetes it would think that okay, you have stopped that container, you have stopped that container because it has finished its job. Okay, but whenever you have run something, let's say for example you have written java -jar and then you have given something but that file is not found, When file is not found, you will get as a return as error message which is other than 0, which means that is a failure. That failure will cause it to be terminated. Am I clear on this? There is succeeded and there is terminated. Terminated means when your entry point or CMD is getting out with a error code, which is non-zero, right? So when all of your containers in a pod are basically have returned non-zero error status, then it is called as failed. Okay. So, and in Kubernetes, basically what you can do is you can try to tell what is the health of your container, what is the health of your pod, by writing something called as health checks. Okay, for the people who have learned AWS or Azure, remember, while we are creating a load balancer, we write a health check saying that, okay, if this path is pinging, your container is, or your load balancer, your application is working. But if this path is not basically pinging, then it is a failure. Similarly, for a pod, you can write something called as health checks, which we basically call as probes, generally. Probes or health checks, whatever it is, right? So generally what pod will try to tell you is, here is trying to explain, okay, what are the different fields which will tell you what has happened. Okay, I'm not going through to read through everything. Okay, right. Now, fine. Whenever you want to do the health check for your prop, he has given you 3 kinds of health checks. One is you can execute some script. Which is he calling it as exec action. The other thing is you can do a ping on TCP port. If this TCP port is responding, then your pod is in running state. And the third check is HTTP. If the HTTP application is running and you have done a HTTP ping. So in pod we can write a health check. Okay. So for that health check, as long as that health check is basically coming up as okay, then your pod is in healthy state. So if that is an assumption. Okay. Now in that you can write 3 different things, right? You can write exec, where you can write a shell script or a command which will tell whether your pod is alive or not. When I say pod is alive, it is not actually pod. Inside a pod we have container, and inside a container we have our application. So for example, I am running an application which is, let us assume, Jenkins. Okay, so Jenkins is alive as long as 8080 port is working, yes or no? Okay, so I might write a HTTP action over there saying that whenever you try to go to the Jenkins on a 8080 port, if it is responding you some values, then it is alive. Similarly, when I am running a MySQL in a pod, MySQL will be alive when your TCP socket, which is 3306, is responding. If 3306 is not responding, then MySQL doesn't have any meaning to it. That's how. So for whatever application that are running inside your pod, if you want to find out whether they are alive or dead, so for that we can write these health probes. Okay. So, and all of this will have implications with your state, pod life cycle. So what are the different states which pod can be present? Okay, right. Okay, fine. This is all fine. Okay. Yeah, interesting thing. So pod has something called as restart policy. Okay, are you seeing restart policy? And restart policy has 3 values: always, on failure, never. So when a container inside your pod is basically stopped for some reason, do you want the pod to be restarted or not? Okay, the default value is always. So for example, in a pod, if you write some container and that container is crashing, pod will always try to start that container. Okay, but if you put it as never, it will never try to restart your container. And then the third value is on failure. Only when your pod has a failure state, then only it will try to restart your container that is running inside a pod. Okay, and this restart policy has an implication to your state also. So generally, right, no one writes this in your the spec YAML. So remember, yesterday we were constructing a pod spec YAML. In there we will have a section called as restart policy. We will not write it because it is not a required field. But whenever you have not written it, indirectly, internally, what is happening? Internally, if your container is getting killed for some reason, your pod is trying to recreate it or restart it. Okay. So, but if you don't want that to happen, Okay, then you have to put your life cycle policy to either on failure or to never. Okay, there are loads and loads of things that happen inside a pod. Am I clear on this? Yes. Okay, right. So now in the pods they have created something called as init containers. So inside the pods we have a different kinds of containers now, which are called as init containers. So init containers, these are the containers which will execute before the main containers. Okay, init containers, okay, are supposed to be executing only for a certain time. Okay, so for example, let us assume this condition. Okay, I have a pod. Okay, let's assume we have a pod, okay, spec, in which what you are trying to do is you are trying to run Jenkins. Okay, but Jenkins is a main container. But before Jenkins, what you have done is you have created a init container 1. Okay, here, okay, you have written ping -c for google.com. Okay, what this command will do? This command will ping to the Google 4 times. This, why are you doing this? Because you want to find out whether internet is available on this container or not. Okay, so let us assume, okay, we have written one more stuff, init container 2. Here you have written, okay, something like ping -c for, let us assume that you are depending on some Artifactory server for doing something. So qt.artifactory.com. Okay, so what is that I'm trying to write in init containers? Some preconditions. Before you run your container, if you want to check some preconditions, or if you want to set up something, okay, which is basically something which you want to run as part of your pod. Okay, if those are not working, if you don't want to write a pod, you write a shell script saying that as long as internet is available, internet is not available, don't create a main container, because it doesn't make sense. Your application will not work if it doesn't have an internet connection. Then why do you want to start your application, right? So init containers are the containers which will start before your main containers, and init containers are supposed to have a fixed lifetime. They are not supposed to run forever. Okay, so whenever you write multiple init containers, what happens is first init container 1 will be executed, and then init container 2 will be executed, and then the Jenkins stuff. We will do an example on this. But why do I write a init container now? I write a init container so that I want to verify certain stuffs before I start my actual application, before I run my application inside the container. That could be a check, that could be arranging something inside your container, right? So for example, in some of the Java applications, generally what happens is your first execution will be dead slow. Your first execution will be dead slow because we have something called as cold and hot there. Okay, so now let us assume that you have started your Java application, and then you start one more test container, and in that test container you will write one init container. The responsibility of that is to ping the Java application so that it becomes hot. Okay, so for example, if you want to do something like this, okay, this is not a main action, this is not an infinite action, this is something which you do only once, that too while your pod is creating. Okay, so you can write as many init containers as you want, but init container is a precondition so that you verify, okay, certain conditions. Only after they are finished, then your application will be started. Am I clear on this? Am I clear on this? Right. So we are not discussing service mesh, but in developer architectures there is a concept called as service mesh. Okay. So in service mesh, what happens is we have a main car container, right? Yeah. So along with that main car, there will be one sidecar in every pod. Okay. That will be doing some administrative actions for the service that is running inside the main car. That's the whole point. Okay. So before that, if you want to check any preconditions, then you write init containers. Clear on this? So in the pod, I have actually two categories of containers. One is a normal container, the other one is a init container. Init container should not run forever. It should run only for a fixed period of time. Okay, and init containers are always created before main containers. Clear on this? Okay, right. Now, along with this pod, we'll have, okay, I'll be adding the things. We'll have something called as controllers. What are controllers? Okay, controllers control the workload objects. Controllers control the workload object. So for example, I want to tell that I am running a Jenkins pod. Okay, but I want Jenkins pod. How many Jenkins pod will you create? One. Okay, I want to ensure that there is always 3 Jenkins servers which are running, 3 Jenkins pods which are running in my Kubernetes, because I want 3 of them. I want 3 of them. So in pod, what is that we do? In pod, we'll create only 1. But over here in controllers, what is that you do? In controllers, we control workload objects. So for example, okay, your application is 10 microservices. Each microservice is a pod. Each microservice is a pod. So for each microservice, you have written 1 pod. But actually what has happened is now 1 is not enough. For some microservices, you want 3 pods, right? So we can't basically go and say kubectl apply, because kubectl apply will create only 1 pod with the same name. Now when you want to create 3 pods, 3 pods cannot have the same name. That's one conflict. So you have to change the names. You will have some administrative work to be done. So what basically controllers do is controllers will control that. So for that, we have first controller, which is called as replication controller. So what is this replication controller? In replication controller, we can set number of pods as the desired state. Am I clear on this? So whenever you are running your application, okay, now let me use my own image. So let me call, okay, this as a pod. So this is our pod, and inside the pod, what happens? You will have some container. I am drawing only one container at this moment. Docker, yes. Inside the pod, I'll have a Docker container. Okay. Now let us assume that this pod is running your web application, or let me put Tomcat. Am I clear on this? So this pod is running a Tomcat application. Okay, right. So in pod specification, you will try to tell this, and you will try to tell that, okay, my pod will run an Docker image, which is whatever Tomcat image which you want to. Okay, and my pod will be running a container which works on 8080 port or 8090 port, whatever port it is. So in pod, you are not worried. Basically, your state is all about information about your container. Information about your container. Now, this is good. This looks okay. Okay. But the problem is, okay. And one more thing, last thing. Okay. Every pod will have an pod IP address. Okay. So let me call this IP as 10 dot. Okay. Let me not worry about it. You will have a unique pod IP. Okay. So whenever you create a pod, what is that I'm getting? I am getting a container, and in the container my application is running, and that application might expose some ports. Since I am creating a pod, every pod will get an IP address. That's it. That's the state of your pod. Okay. Right. Now the problem with this approach is it is good. Okay. But here there is no desired state. Okay. The desired state is containers running in your pod, which it is trying to do. I have just now said that pod will not be deleting itself. Pod will not be dead. Pod will always be running. We have something called as restart policy. In pod, the desired state speaks about the containers that are running in your pod. Okay. And now, if I want to run multiple pods, then what I do is I will not write a pod. What I'll do is I'll write a replication controller. And replication controller will not speak about. Okay. We will try to tell to our Kubernetes master, okay, saying that replication controller, where we will try to tell that I want 3 pods. I want 3 pods. So your desired state is 3. Then what happens? Basically, on whatever nodes it might be, okay, so it will create 3 pods for you. Am I clear on this? And every pod will get a unique IP address. Okay, so I will write the IP addresses inside this itself because it is much more readable. So I'll be writing this as, let me write some dummy stuff. 192.168.10.11, 192.168.10.12, okay, and 192.168.10.14 for whatever reason. So we are getting 3 pods. So what is replication controller's actual state about? How many pods should I run? So in replication controller also, remember we have a specification, right? So for any Kubernetes objects, what is that we'll be writing? We'll be writing API version. What is the kind of an object which you write? What is a metadata? And what is a specification? In replication controller, the specification is all about telling how many pods do you want and what should pod have. How many pods do you want and what should pod have? Am I clear on this? Yes. So we have something called as replication controller. And why do we use replication controller? Because we say 3 pods. Now, generally let us assume that for some reason, the node that is running this pod has been dead. Then what Kubernetes will do is, what is Kubernetes' responsibility? To ensure actual state is equal to, so it will bring one more pod and you will get 192.168.10.24, and let me change this color of it. Sorry, getting the whole point? So whenever we scale, we use something called as replication control, right? So we have a replication. Okay. Today we will take some more time in this class. Okay. AWS class might be slightly delayed because I have to speak couple of other controllers and then I'll finish this discussion. Okay. The understanding is easier. You have understood replication controller, right? Yes. Okay. No, that is usually in Kubernetes. Who has an IP address? Your container doesn't have an IP address. Pardon me? See, this is the IP. If your container will get a IP address which is this. If you have 3 containers in this pod, all the 3 will get the 24 IP address. That is so one is crashing in the same IP address you want to 10.12. Kubernetes will not do that. Okay. We need to know more Kubernetes before application knows it. మనం మాట్లాడబోయే నెక్స్ట్ టాపిక్ అదే, రైట్. కొంచెం ఓపిక సార్, అన్నీ అవ్వలేదు, నేను ఇప్పుడే చెప్తున్నాను కదా, రైట్. సో డెవాప్స్ Kubernetes. So yeah, for the people who have asked me how will application know, let us assume in your company you have one server and you have an IP address of that server. That server is crashed. Okay. And one more server has taken from DHCP has taken that IP address. You don't have that available IP address. How will you resolve now? Pardon me? Naming. Okay. You cannot give names. Let us assume DNS names are not available. Okay. Naming is one of the option, but yeah, let us assume you don't have names. How do you do that? Do we have something called as reverse proxy or load balancer? Yes. Okay. మనం ఇంకా అక్కడ వరకు వెళ్ళలేదు దీంట్లో, right? The moment we go there, you'll have similar answers. Yeah. Okay. Fine. Okay. Cube 4, right? So I'm just drawing this replication controller. Okay. So I'm just trying to give you an overview. We have to write a specification for all of them. Okay. So preview dot slash images slash cube4 dot png. We have something called as replica set, which is also almost similar, but with one extra feature. I'll speak about it at a later point of time. But I have one thing called as daemon set. Okay. So what is this daemon set? Okay. Remember we have a pod now. Okay. Let me take this pod and let me build a new image. So in replication controller, what is that you have said? You said that I want 3 pods. Daemon set works in a different way. So we have, let us assume this is Kubernetes master. And then let us assume that you have 3 nodes. So let me call it as node 1, node 2 and node 3. And what you want to create is, you want to create a daemon set. In daemon set, you will not tell anything. You will just tell what is the pod which you want to run. What is the pod which you want to run? What is the network configuration of it? And the responsibility of the daemon set is to ensure that a pod is created. Whatever pod which you're asking is created on every node you have on a Kubernetes cluster. Are we getting this point? Daemon set is all about creating one pod on every node on your Kubernetes cluster. Am I clear on this? Right? So why do we use this kind of pods? Remember logging agents? We have some log agents. We have this agent kind of softwares which we want it to be running on every node. Okay. So that is the case where you will use daemon sets. Mostly will be using replication controllers, but there is something called as daemon sets. Daemon set ki replication set controller ki teda enti? Replication controller is all about number. You tell me 100, it doesn't know how many nodes it has. If you say 100, it will try to create 100. Okay. But when it comes to the daemon sets, it creates exactly one pod on every node in your cluster. That is what a daemon set is. Okay. Right. So we have something called as daemon set. Okay. Creates one pod on every node in Kubernetes cluster. It is used majorly for agent softwares. Whenever you have some kind of an agent that needs to run on every node, then you will use it. Okay, right. Okay, fine. Okay, right. So we have I'll speak about something called as services. Okay. No, I'll stop it over. We'll discuss about service. Okay. So when I speak about service, that is where your question of saying that, okay, if Kubernetes IP address is gone, if pod loses its IP address, how will I solve that problem? That will be the initial stuff we'll discuss. So we have to understand three major what do you call stuffs still. One is something called as service. The other one is something called as volume. Remember, we have that existing problem in Kubernetes saying that in Docker saying that whenever you run in Docker, okay, whatever data that is generated by your container will not be present or will be removed if your container is deleted. Okay, so we'll have some kind of same problem on Kubernetes also, right? So let us assume that in Docker I have created a volume. So how can Kubernetes help me with volumes? That is the other stuff. And then we have something called as stateful set. Stateful set. Okay. And then we'll get into deployments. Deployment is all about doing one shot. Okay. So that is the basic stuff. So we need to understand service. We need to understand service discovery and all of that stuff. But in pod, did we understood pod story now? Okay. Today I don't have time to answer your questions. I'll definitely answer them tomorrow. But every pod can run multiple containers. And there are two kinds of containers in the pod. Okay. Init containers and normal containers. Normal containers, pod will try to run them all the time. Okay. But when it comes to init containers, they will be created before your actual containers are created once they have finished their execution. Okay. So I basically, whenever I'm writing a pod, I have something called as restart policy. Okay. I have something, every pod might have a port. So there should be some way to expose the port. Okay. So we have not spoken about volumes, but every pod might also have a volume. All right. So, right. And then we said that in Kubernetes, there is something called as controllers. What is the responsibility of the controller? Responsibility of the controller is to ensure some state which speaks about pods, not what is happening inside the pod. Pod speaks about what is happening inside the pod. What are the images that are running inside it? But these controller objects don't speak about that. They speak about number of pods, or they speak about how many pods do you want, or they speak about on which node my pod should be running. Okay, all of these kind of stuff. So for that we have discussed two kinds of simple controllers today. One is a replication controller where you simply worry about number of pods. Okay, when you say in replication controller, I want that pod, whatever that pod is. Okay, and I want 5 instances. So your desired state is run a pod, whatever pod which you have created, in I want 5. So and now Kubernetes will try to ensure that the count is always 5. Even if one of the pod gets deleted, Kubernetes will try to launch one more. Yeah, am I clear on this? Okay, and then we have something called as daemon set. In daemon set, what is that Kubernetes will try to do? It will try to create that pod on every node. Okay, and obviously if some node due to some failure, if the pod is deleted, it will try to recreate. That is basically what happens, because here the desired state is run one pod on each node. Right, tomorrow if you add a new node 4, there is no need for you to create a pod. It will automatically launch that pod on that node 4. Am I clear on this? Right, kotta node vachinapudalla aa pod run ayipoddu automatic ga andulo. That is what a daemon set is all about. Yes. Okay, and then we have to worry about service, volume. Okay, and then there is something called as stateful set. Then we will go towards deployments. Right, and once we understand all of this, then we'll start writing specs. Once we start writing specs, then we'll take these specs and do the deployments on Amazon EKS and Azure AKS. Because once you know how to write specs, it is all about which cluster you want to deploy. Okay, and let it be anywhere. We will be trying to use kubectl, but Amazon has given some extra options. Kubernetes or what are the extra options that Azure provides, that will vary when the time comes. Right, Clear on this? Okay, right. So I'll stop it at that, and tomorrow we'll start with something called as Kubernetes service. I'll speak about understanding first, because first if we understand what is happening, then we can definitely write specs. Okay, right. And I'll be referring to the Kubernetes official documentation, and I would expect everyone reads that. Right? Okay then. So today I don't have time to take your questions. Okay. So we will take your questions tomorrow. You can start with the questions tomorrow. Before we start the class, anyway, we have some spare time, right? So in that time, type the questions. I'll try to answer them. Okay. Classroom lo kuda ante. మనం రేపు దీని గురించి మాట్లాడదాం. But on a overall note, it was not a very difficult decision, a difficult discussion which we had. We had very simple discussion. And today your responsibility is to go and read the pod reference which I have given there. So pod I have given an official document link. Please go and read it. Yeah. Okay then. Thanks, man. Thanks for your time. Abhinay, I'll be speaking about this tomorrow. I think I'm running out of time. So for that reason, sorry for this. Yeah.